So let's continue our discussion of conic sections. Now, in this we saw how an ellipse relates by the definition as a locus to the actual cone. But this is not just limited to the ellipse. We can extend this idea. This idea can be extended to a hyperbola. So let's take this cone again. Now let's take our hyperbola. So the idea is we want to adapt this to this. So let's again inscribe two spheres in the cone tangent to the plane. But now we're going to have them on opposite sides of the vertex. So we've got one sphere on this side tangent to the plane at a point A, and one sphere on this side tangent to the plane at a point B. And so now I claim that A and B are the desired foci of our hyperbola, and that the length sigma, which we now replace by, we now want the absolute value of the difference, that our length sigma is again the length of a common tangent to the spheres. And these are all equal by the symmetry argument mimicked from part 3. So why does this work? Well, if we take a point P on this side, then PB is the length of on the cone and on the plane. PB is the length of a tangent from P to this circle. So it's the same as the length as if we took it along a line through the vertex of the cone along the cone. But also, PA is the length of a tangent to this sphere, so it's this. So then PB minus PA is this minus this, which is this. And so that's where, so in that case we get this. And on this side, we get PA is again the length of a tangent, so it's this long segment, and then PB is the length of a tangent, so it's the shorter segment, and then PA minus PB is this. So in all these cases, we get this. And these aren't really rigorous proofs because I haven't really shown that like all the points that satisfy this are on the ellipse or hyperbola respectively in the past 2 videos. And I haven't really shown that these two spheres exist, but the arguments are so nice that this shows where it all comes from. So I think you can forgive the lack of rigor. Thank you. Now, you may be wondering if a similar argument exists for a parabola. The answer is, I'm not really sure. I would suspect so, that such an argument would start by taking another, similarly taking a cone, and then this. But now we hit the problem that you only have one sphere that you can inscribe that's tangent to the cone and the plane. It's this one. So I would suspect that this point of tangency will be the focus. But yeah, so and maybe we could take the directrix to be a line through a plane parallel to this. But I'm really not sure. maybe a proof along this line. Maybe we can do something along these lines to establish why all these points on this section lie on this parabola. So if you think of anything, feel free to write it in the comments or send me a message. So that's all I have for this video, but in our next video, we'll discuss the nice properties of the parabola and how they relate to complete quadrilaterals. So stick around for Conic Sections Part 5. Thank you for watching, and I hope you'll follow me on Twitter at Luke_Robitaille. Thank you.